Hey, differential equation students. We are still solving systems. The difference today from what we did before Easter break is that we're dealing with complex eigenvectors and eigenvalues. So I'm going to take you through the steps here. Here's our new matrix. So I'm going to go ahead and enter that in with linear algebra. Here I am finding the determinant, as always, to find eigenvalues. I do that and I solve. And we've got i's in there. Oh no, what are we going to do? All right, please note that first off, that what we have here is a conjugate pair. It's the same value except we've got a plus and a minus. I'm going to tell you right now that when you're finding solutions, you only need to focus on one of these, and I'll show you why as we get out a solution. So what I've done here is the reduced to our echelon form of our matrix, and I've subtracted that first eigenvalue, the 1 plus 3i. Let's see what happens. Aha. Note very carefully, we've got a 1, we've got an I. All right. So if I am putting together a solution, I'm just going to call it solve for right now. Then what we want is to put in a vector, our eigenvector. Well, let's see, one possibility is I could have minus I for the first and then 1 for the second. And if I multiplied 1 times negative I plus I times 1, yay, that's 0. Now I have to multiply times the exponential. What we do is we put in the eigenvalue, 1 plus 3i times t. Okay, well that is not really helpful at all because we don't want i's in our answer. So what are we going to do? Well, we're actually going to rewrite this. So if you remember, when we did this back with second order differential equations, the e to the 1t, that's fine. That's going to be e to the 1t. But e to the 3i times t is going to turn into cosine and sine using Euler's formula. So a better way of writing this is as follows. We want e to the t times cosine of 3t plus I times sine of 3t. Okay, I'm not saying that's super better, but it's a little bit better. We don't have imaginary numbers in the exponentials. What we want to do now is we want to pull out the imaginary and real part of each one of these coordinates. The imaginary part will give us one solution. The real part will give us another solution. All right, so let's do this, and I'm going to give you Sol 1. All right, what we're going to be focusing on here right now is the real part, okay, the stuff that doesn't have an I in front of it. Now that's pretty easy on the bottom because that's just going to be e to the t times the cosine of 3t. That's the real portion. We got an I there in front of the sign. But we got i's in front of all this stuff. Well, note something. I times I is negative 1. We have a minus sign in there, so we have a positive 1. So really, the real part on the top is e to the t times the sine of 3t. Okay, because that's if we multiplied through by I, we'd get e to the t times positive sine of 3t. That's our first solution. Okay, for our second solution, we're going to look at the imaginary portion of that vector. And we can read that off here from the top. What we're going to have is, well, I better put a minus sign in front of it, minus, e to the t times cosine of 3t. And on the bottom, we're going to have e to the t times the sine of 3t. That's the imaginary portion there. That's the stuff that's got i's in front of it. Those are our two solutions. Now, I'm not going to go much further with them in this video, but of course, you can take the determinant and show that they're a fundamental solution. You're going to be doing that in class. Let me just plot the trajectory of this system to show you what's different here. Look at that. We're getting spirals. We're getting spirals out. No more lines like we did last class. Everything is moving out, and it's moving out because of that e to the positive t power. All right, we'll discuss this more in class on Wednesday.